swimming pools, and about 3 times as deep as those would be. So it's been a few years, so I can't remember the gallon content, but nonetheless, it's full of all those products, full of VOCs. So when we're recognizing how to reduce costs, the idea was just to figure out how we could clean the stuff, the paint sludge. I'm not a big fan of that word, but that's what it's called at Ford Motor Company. And also to get back to the name, when we made this product, they started using it and they pushed the project through with that as the name, Ford Sludge Remover, because they didn't know what to call it. So they did that, and once you write the first project, that's what the name is. So we just condensed it to FSR. So they had something more appealing to call it. The big thing about this was that no matter what we brought in there, the ultimate piece of the automation process that Henry Ford brought to everybody was the production line or assembly line. And to slow that down for any reason is really cost by the minute to Ford Motor Company. So you can't have cleaners in there that are going to cause paint craters or any defects of any kind. So they really watch what you add into the paint booth process. If we knock that 85 to 90 number down per hour and we go to 60 because we have a crater catastrophe, then that's not going to be looked at well, and it will get the project either put off completely or put on the back burner until we solve it. So you can move on to the next slide. Okay, I don't know if you want to speak to this one, Punch, but
well, what we tried to do in this situation was create a product that would dramatically reduce the VOCs, where the main constituent is water. One of the things that we needed to do was to make sure that when we used a water-based product, that we would still have the evaporation consistent to or close to a solvent evaporation rate. Because if they were unable to drive on the surface with the forklifts or any other equipment, that would thereby increase their labor expenses, just because people would not be able to work in a safe situation.
You can go to the next slide.
We have the next. There we go.
Okay. This is a snapshot of an Excel spreadsheet used within the Ford plant to show VOCs. I don't have a mouse to click over the cells, but if you can follow me, the top one is the LubTech FSR Ford Sludge Remover. That's our product. That's our Ford product number, TOX number. If you look at the VOCs per gallon, that's if you're looking at these in gallon for gallon units. Now what we found is that this is far more impactful than it looks on the surface. If you look down below at the Cyclosol 53 and the wash solvent, you'll see their VOCs in pounds per gallon are 7.26 and 3.36, which is equals to about 5.45. Now that's through a nozzle at high pressure. Okay, so we're talking about 5.45 on multiple gallons. Whereas with the VOCs from the FSR, we found out that we could use it repeatedly. So we may only need to use a small amount, and maybe 5 gallons to clean an entire booth, and have it be at 3.25 gallons. So these numbers are very conservative. The time that we made this, when we threw it up and it was about 90-some%, we said, well, we've got to be a little bit more we can't show them everything right away, because the cleaning usage, it was 5 times more with the Cyclosol 53 versus the wash solvent, and actually it was more like 8 times more. But we didn't want to make it unrealistic, so we gave ourselves some number to shoot for. So you can, yeah, I guess we'll just continue there. The big thing is that the plant is always going. There's 3 shifts. There was a day shift, a night shift, and then a midnight shift in between those, to do maintenance. But they were running 4 10-hour days, sometimes 5 10-hour days, and getting maintenance time is difficult, so when people needed to clean, the booth cleaners needed to get things done, the cleaners that have been tried in the past that were not solvent-based were extremely slow. You had to have a lot of dwell time with them. So you put it on, mop it on there, and you know, you'd have to wait 4 or 5 minutes and then come back and mop the area, which then, after that was done, it was slippery. So you had to wait even longer for it to flash so it wasn't slippery anymore. And some of them actually left a long-term, long-lasting oil film on the surface of the stainless steel floors, where the paint people, which you'll see soon, where the paint people would come out of the booth. They track it all on the floor, so the stainless steel floors, the concrete floors would all become purple with this sludge. Another thing is that with or without breathing, safety precautions taken into concern, or rubber gloves, the people that were cleaning the booths and cleaning the floors were using straight solvent constantly. Xylene, toluene, wash solvent, whatever they could get their hands on. And that's just, it's not okay. It's not safe. And even though they're used to it and they've been doing it for years, you know, why not have a better alternative that works better, it's safer? So the problem is it was tough to do. So, and we figured that out when Punch came up with 17 different formulations. It was the bouncing ball effect, and I'll let her talk about that. But there are various types of paint chemistry within this one building. You have electrocoat deposition, which is the very first film on the unit as the truck comes over from body. It's just a one full body of a truck, no engine, no compartments, just sheet metal in the shape of a truck with galvanized steel. Then it goes through a phosphate process where they clean off all of that, all of the galvanization, and clean up that metal and get it through metal prep, sand off any of the imperfections. And then what they do is they charge the carrier positively, and they dip it into a 3,000-gallon bath of electrocoat deposition, which actually bonds to the metal, which prevents rust. After that, it goes through an oven. From the oven, there are rollers that this electrocoat deposition would ooze off of the truck when it was done and leave lots of deposits there. Then it would go into the prime oven, or prime booth, get painted in prime, various colors of the prime, and then it would go through the oven. After that, it would go through base coat, and then the monster of all of these is the clear coat, which is essentially a liquid glass almost when they put it on. You'll see pictures of it when we were trying to get it off. But so she had to not only create it for one area, but for all of these areas, and then refine it so that we had one fluid that could take off all of these products. So that's why she got to 17 formulations.
Basically, what I tried to do was to take one area at a time, take one situation at a time. So we'd solve the problem in one area. We started on the paint booths first.
Yeah.
Started on the paint booths, on the interior of the paint booths. We solved that problem, and then we moved on to the windows that are in each paint booth. We needed a product that would remove the e-coats and the clear coats from the windows, but would not streak the windows and would dry clear. From there, we moved to the floor situation, which actually took longer because of the necessity of reducing the surface tension as well as reducing the drying time or increasing the evaporation rate without decreasing the flash point. So those were some of the parameters that we needed to look at in each situation. And another characteristic that we wanted the product to have was not to dilute the paint, not to dissolve the paint and to dilute it, but to actually remove the paint from the surfaces, break the paint bond so that we would have the paint separating from the cleaning solution so that the cleaning solution could be reused, which was not true for the solvent. That product once used, was done. It was spent.
So you can go to the next slide. Okay, so this is a crater test, and what this means is that we can't do any testing within the booth until we can assure the plant manager, the paint area manager, all the robotics and automation experts out there that our product is not going to cause crater issues in every unit that they paint. This goes so far as that if people were on the line that were using the wrong type of deodorant with any type of silicone or anything like that, they would have them do a shake test onto a metal panel and then spray these panels. And if the person was using the wrong type of deodorant for that day or wearing a perfume or something, they were asked to leave the booth and they were done for the day in there. So they ran this really tightly. You had to go through a Bellinger blow-off is what they call it to go in and out of the booth, so they blow you off so you're not carrying any particles. But what this one is they take the panels, they run it through E-coat, base coat, E-coat, prime, base coat, and clear coat, and they see how the product reacts in 3 different situations. One is that the product vapors are applied to the surface, then the product's actually dripped lightly on it, on a panel, and then painted. And then the third one is that it's just flat out dunked in there or covered with a soaking rag with the product and then painted over. And if you look at the main companies, this is an example of when we did DuPont. But DuPont, BASF, and PPG paints, which are the most widely used in Ford Motor Company, this passed on all of those accounts. So when we got this, we did a collective dance in the lab that we passed all these because now that meant that we could trial everything. And this was another big breaking point for us, or a tipping point. You can go on to the next one. This is kind of the control process for analyzing how we paint out of the gray coat paint guns and to see how much they would fill up in a bucket of the solvent coming out. So what this is looking at is if we're going to know how much paint they're going to use, or excuse me, not paint, solvent they're going to use for cleaning the paint off the walls, we have to know how many gallons per minute are coming out of the nozzle when they're trying to clean it off the walls. And then we would use a stopwatch to see how long they were spraying the walls to clean them, and then we knew that they were doing so many gallons per minute. So that's what this is. Okay, this is a schematic, and I don't know if you can all see the colors on here. The long and short of it is this is our initial run at breaking down the paint plant into the different areas of process. So we have the beginning all the way through the end. And now if you can just see what's white, those are the only places that we weren't able to find a use for FSR within the plant versus the solvent. Initially it started with the green areas, then we added in the orange areas, and then we tried the blue areas, and it worked there at these different these applications. And then we went back and tried the gray areas. The gray areas come with heavy grease, oil, everything else. I wasn't sure if it was going to work or not, but it cleaned off that stuff. So if you look at all the rest of them, all the white have areas where it's not applicable. So the colored areas are different areas that we tried the FSR, and it was successful. Okay, so here's kind of the cliff notes of why FSR was better than the solvents they were using. The flash point improvement, taking it from 82 up to 145 degrees Fahrenheit. It's obviously safer. There's a monster deluge in any of these booths that if there's a flash, they dump hundreds and hundreds of gallons on the people in there, the units, everything, so there's not a fire. So raising the flash point was a big deal for Ford Motor Company. The PPE standard reduction was the proper protective equipment. That was one item. While we always preach about being safe, this was certainly taking these people out of the realm of being around hazardous solvents constantly and getting you into something with a neutral pH. Obviously, the increased air quality is better. The reduced threshold limit value from OSHA was just a big deal in the fact that they didn't have to wear respirators just to work around it. it wasn't actually even necessary. But then the big one at the end was, did it work? Yes, it left the floor clean, and then it was dry and ready to walk on. Because what the painters come out of the booths, where they're going from sticky sludge type material on rain boots or rubber boots, they walk through a solvent mat and then onto a stainless steel floor. So if that's wet at all, there's a real high probability that the people coming out of the paint booth covered in paint and onto a solvent or wet floor, that they could have a fault. Next slide, please. So again, back to our solvent savings. If we're looking at VOCs, we'll get into the cost after this. Volatile organic compounds with the cyclosol 53 and the wash solvent mixture were annualized at about 280,000 VOC pounds per year. The FSR, when we started using that, if you looked at it, we would reduce it down to 34,000 VOCs per year. And the savings here is a big deal because there's a certain amount of money or permit that the Ford plant had to pay to the state every year for what their estimate VOCs would be. So not only is this a monumental environmental savings, it was a significant cost reduction for a plant that was on the ropes and was getting ready to shut down. And at the time, they didn't know they were going to for sure be shut down. So you can look at that 88% roughly reduction in VOCs. And our goal was, again, 3 to 5%. So go to the next one. Okay, so if you look at the cost of material savings alone, you look at the price reduction. With the amount of product that you needed to use for the solvent, 52,000 gallons was on the low end for what they really use. And then 10,500 was really on the high end. But again, we had to make these numbers look, I guess, real. And even though they were real at the other ends of the spectrum, they just didn't seem believable because it's been done for one way for so long. So the material savings is 41,000 gallons a year, and just about $200,000 in straight material savings. You can go to the next one. Okay. Here's another, the time study. This is actually, as good as this looks, this is actually the straw that broke the camel's back for this project and moving it forward. And we may or may not get into that. I don't know if it's an effective use of our time to describe why this didn't work as well. But if you look at the booth cleaner efficiency, they would take 6 booth cleaners throughout the plant, and they would take each take a zone to clean. The labor hours were pretty intensive, and these people had to work fast. So what we did was we did a time study calculation on them. We 4.5 total hours per booth using the old method and products versus about 0.75 or 45 minutes total hours per booth using for the FSR. And you can see directly what happens with the labor savings there. It's an 83% reduction.
I think one of the other important things to keep in mind is that these are not Lubtech numbers. These are Ford staff numbers. We worked directly with the Ford staff so that we could verify all these numbers. And then the next slide, please. So we have our material savings of approximately $180,000, and we have our direct labor savings, which was another $96,000. The total savings to the St. Paul plant per year was then $293,000. And this takes into consideration only labor and material. We could also add to this number any money that we saved that they did not need to pay VOC permit dollars for.
Yeah, so for that number, they were paying $1,000 for every $2,000 of, or 2,000 pounds of VOCs.
So 50 cents a pound.
Yeah, and that ends up being quite a substantial savings on top of this number here. Okay, you can go to the next. Okay, the way that we had it set up right now was, you know, the product that they were using was one that I brought in with our other company that was a good product, and it worked really well. It was, the way that it was used was not exactly indicative of a good process because it had changed over the years. Initially, what they were using was a really good citrus-based cleaner that, when applied at the end of a shift, would clean very well, and it would just have some dwell time. It just took a little bit longer to dwell. And putting it up on this stand here was okay, but when they ran out, the tank would stand up there and you couldn't see what was in it. People wouldn't reapply or reuse it. They wouldn't like pull that one down and put another one up. They couldn't tell how much was in there, and so they would just start using the solvent. So while everything was working okay with it, it just wasn't a good process for them to be able to see. So we brought in a clear tote. They were able to see when it was empty or when it was getting low, and they would repeat their orders, and it was easily accessible. And we were getting it pumped. It actually got to the point where it was pumped throughout the lines. Small change, but the new procedure made it visible and easily usable. You go to the next one. Okay, here's the product that we're talking about, the electrocoat deposition, or the E-coat. As the product, if you look at those two bays there, that's where the trucks go up into the oven and then come back out of these two bays as or actually this is where they go up and in. So the trucks come around on that left side, they come across these carriers, and then they move into the oven. When the trucks are wet, the trucks emit of gas or vapor. I'm not sure that's for a chemist to say, but it ends up compiling on all of the metal or moving parts there, and it ends up being like a grease. It's real sticky. It's real thick. It adheres to the surfaces really well, which is what we don't want it to do. So, you know, I asked Punch if that would work on it, and she said, I don't know. We better go try it. So we went and tried it, and it took it right off. It cleaned it up really easily. The process before was to take a knife of some kind and cut it off, which obviously was a shutdown project where they would let it build up as much as it could build up, and then they would go out there with like a putty knife or something like that and scrape off all the rollers. Well, now we could walk down there and apply the product either with a mop or just spray it on there with a little handheld air pressure sprayer, and then walk away from it and then come back to it and essentially just go over it again, and it would come right off. So we were finding more and more uses for it all over the plant. You can go to the next one. Okay, this is the trial that we were looking for. This is inside the paint booth, and you can see down at the bottom underneath the glove, the person's glove, there's all those lines. Those are the different colors that come out of that closet, and the person can connect and manually cut in and spray the trucks going by. What you've got here is paint on the wall, and the overspray from the product, or from the paint products, hitting the truck body and then kind of bouncing back, going up into the air, being pushed down to the downdraft, and ending up on the wall. That's that purple color. So spraying that down was the way they cleaned it. And you can see on the left, they would spray roughly 450, 500 gallons of solvent in a given booth area after every shift to clean off the paint and to keep the windows visible. But all you had to do was take a 5-gallon pail of the FSR, take a little handheld mop or a floor mop and put it on to the wall, and then go down with a squeegee, and you can see the clear difference there without standing and spraying, creating all this overspray of solvent off of the cabinet walls into the air and breathing it. You simply just go up there, mop it on, and wipe it off.
Previous to the FSR application, when they were cleaning a booth and spraying the solvent, they would spray approximately 400 gallons to clean this paint booth. After the modifications of the FSR, we were able to reduce the usage per paint booth to 5 gallons. So we reduced it 95%.
Well, not only that, too, what we found is one of the guys got done using the product in the booth, left the bucket outside of the door, and the next day he went to use it again. Well, all the solids had separated out, and he was able to use that same 5-gallon bucket for the next day. So instead of 400 gallons again that day, he used the same 5 gallons that he had used previously, and it worked just the same. So they were able to extend that, and typically after a week they would go and dump that 5-gallon pail. So not only is it 400 gallons per time, but it was 400 gallons on Monday, on Tuesday, on Wednesday, on Thursday, and Friday, versus just 5 gallons for the week. You can go to the next. So the process on the left, and this is actually in the clear coat section now, was to just spray it with that gray coat gun and wait until it was just about able to be seen through it, but it left hazy windows, and you're using 5 gallons, a gallon a minute, and you got it about 80% clean. You can see on the right side there where the gentleman is using a dampened mop head. He goes in there and just wipes it on and then squeegees it off for 100% clean, which took way less time. I mean, you're using 5 gallons in 5 minutes, or you just wipe that down in 10 seconds and then squeegee it off in another 10. You got the totally clean window on both sides in less than a minute. So we can go to the next one. Okay, this is a continued look at the same area. You know, I think this is more of the same, just different processes. And then this is the result. And we're looking at, you know, if you look at time is the bigger one that could throw this off. If this took us, you know, a half hour on the right and that was within 2 minutes on the left, that would be one thing. But actually it's 3 minutes on the left and 2 minutes on the right. So it's actually faster. It comes out looking way better. The other thing is that if you can imagine the left window being super full of, and being hard to breathe next to, whereas the one on the right, there's no smell at all. Like there was no solvent smell. So you're looking out a clear window, it's not hard to breathe, and you're not wondering what you're smelling. If you walk to the one on the left, it's the same window, except for there's a heavy solvent smell, because they just got done pushing either wash solvent or straight xylene onto it. You go to the next. Okay, so this is this is in the clear coat section. This is our toughest area. This is where the gentleman there on the right used 496 gallons, and it took him 4.5 hours to clean to the satisfactory level, which was determined. Right now he's shooting off all the hoses and getting all the purple sludge off of the paint hoses. And he was able to do that with just a little hand pump spray out of that same 5-gallon pail. It just went on top of the white bucket there, and he would just pump it, and it would build up just a little bit of pressure, and he would just squirt it on the hoses. So this less than 5 gallons, and he cleaned the entire booth in 45 minutes. It just, when we saw it happening, it was unbelievable. The guy was absolutely thrilled by it, but the other people that were supposed to be cleaning the booth with him for the 4.5 hours were less than impressed, because they had nothing to do, and their hours were getting cut. So that was the big drawback of this whole project, and where we caught some resistance. You go to the next one. Okay, more of the same. This is in the clear coat section. Now, this is the one I was talking about, that it was essentially like liquid glass. If you look at any car right now, you've got your clear coat, and that's what makes it shiny, and it gives it a rigid outer coat to protect against scratches and rock dings, all that type of thing. Well, when you spray that in a booth, it doesn't get the chance to go through the oven and bake off all the solvents to become hard. Essentially, it just gets onto the windows, and it creates you know, semi solid on the windows. It hasn't, eventually as it sits there longer and longer, the solvents evaporate out of it and it becomes harder, but it's not like when it goes through an oven. So you'll see on the next slide how they cleaned it off. That was the best way to do it, was this. And that is to take a razor blade. Now this wasn't standard practice. They wouldn't do that obviously because of the danger in doing the razor blade, but for the purpose of our trial here, they were showing how you could get it off, and it was with a razor blade. Otherwise, it just didn't get off. You couldn't get it off. You'd use solvent. You'd have to wait until the plant was down and then come in with some sort of a knife type thing to get it off. Well, on the right side, you see where it just comes off in sheets and in blotches with the FSR on it. So you put it on, you squeegee it off. I mean, obviously that's way safer. The actual left side wasn't even an option for Ford. That was just, again, to show what it took to get it off. It was a razor blade, and that wasn't actually that wasn't easy to get off with that razor blade either. You can go to the next one. Okay, here's the procedure after both have been sprayed. This is clear coats on the stainless steel flood sheet. You can see the difference. On the left is where it's been sprayed. Essentially what happens is the solvent rolls right off it, and it leaves just a slight film on there. But you can see that little hole there, that circle in yellow, is where we cut into that with the razor blade and cleaned it off. Now this is the same part down the aisle a little bit, covered with clear coat, where we put the FSR on it. All of it just came off. You could just wipe your hand across it and pull it off. Okay, you can go to the next one. This one is just kind of a loud slide here, but I think the idea is just putting it on the on the floor. And now we're outside the booth and we're on the floor. Before they used to use a really drenched wet mop. So again, we're using more and more and more of the product. And they would mop it onto the stainless steel floor, clean up the paint sludge, and then let it evaporate into the air. The new application is we wanted to dry mop it. Punch actually found that less was more here, and you just had to have enough to make the paint come up. So I'll let Punch talk to that.
What we found out is if we used too much, we ended up with kind of a slurry on the floor that wouldn't pick up with the mop. So by fully wringing out the mop, we had just a very, very lightly damp mop, which then penetrated the surface of the e-coat or the paint or whatever was on this floor, and still allowed the paint sludge to be picked up by the mop. If we used a too wet mop, it wouldn't pick up very well at all.
So you can go to the next slide here. Okay, here's an example of the floors. These are right outside the booths that you just saw the gentleman painting. There's the boots on the left bottom little counter. That's what they look like coming out. This stuff is, when you step on it before it's had anything on it, it's ultimately sticky. It's really sticky. It's hard to pick your feet back up when you hit the ground and you're walking. So they have to clean it up for safety reasons on that, to that end. On the right side here, you can see using the FSR application, just squeegee and wiping it, get it super shiny, super clean, and then it's dry as well. You know, it dried within 3 seconds of being applied, depending on if you had the right saturation level. So you can take a look. This one essentially is we changed a couple processes that have really nothing to do with the product, but we're using a citrus cleaner on the right side with a saturated cocoa mat, and on the left side, and on the right side we're using a wire mat that would give us the ability to clean off our shoes and then still have the FSR come up underneath it. So that you can move on from that one. Okay, again, we're talking about less is more with this product. Again, you know, where they were using hundreds of thousands of gallons of this stuff every year, you could really cut it down. So in a given week, they could use 1,600 gallons of solvent, or they could use 5 gallons of FSR. Use it repeatedly and then dispose of it. So One of the big picture items is to get back to what I talked about with the flood sheets at the beginning, when they were spraying the solvent onto the paint that was on the walls inside the booth. All that solvent and all that paint was going down into the sludge pit and then into the DTAC booth. Well, if you're not spraying thousands of gallons a week on the walls and on the floors and on the grates and everything else, your DTAC expense is a lot less expensive, and your VOCs out of that, again, aren't being exponentially raised. So if you're using water-based chemistry that can remove all that sludge, you're seeing benefits everywhere. I mean, in multiple places. So you can go to the next one. This is the last item, but it was a big one. The control phase, and that's training the staff on proper cleaning methods, storage and handling, point of use. You know, when we get into a guided in-plant trial, then we ran into a couple roadblocks, but it ended up being good, and they started using it. Initially, when they first saw it, it took the paint off so cleanly, the clear coat off of the flood sheets, that, you know, and I wasn't able to be there when they first got it. The plant opened at 4:30 in the morning. One of the night shift guys cracked open the tote of product that was there. And he knew what it was because I worked with him, but the people that were with him on the cleanup crew saw him apply it to the flood sheets, and everything that was on the flood sheets came off immediately. Well, they'd been cleaning these for years with solvent, and nothing hardly worked on it. So they automatically assumed that it was caustic and that they weren't going to work with it because they hadn't talked to me about it. So then when we worked with it, I went there and I took it out, and I turned on the nozzle, and I put my hands in it, and I showed them that it was not going to hurt them. And they all kind of laughed, and then they started using it, and they really liked it, until they realized that they were done cleaning 3 to 4 hours before they were typically used to, and then the supervisors were sending them home, and they weren't getting paid for those extra hours. So then we started to find some resistance. You can go to next.
The last part of this is to be able to repeat time and time and time again the process and the overall savings. So what we have here is we've just identified the major areas of application, and we replicated the cleaning in those areas several times, as well as having the staff understand that this was a good thing for them because of the safety involved and the reduced amount of contact time that they had with the chemicals, because in many instances they had personal protection equipment to wear when handling the xylene or the wash solvent, but it's uncomfortable and it's hot, so they did not wear it. So this was a win-win situation for the staff that was using the product. We have the next slide, please. And what we want to do is move ahead, and the fact that we have this Ford Tox number means that this product can be sold anywhere to a Ford manufacturing facility in any part of the world. We primarily worked with the Ford plant, but we have plans to start introducing the product to other facilities. We have the next slide, please. And this is a picture of the Governor's Award. Rich and I are on the right-hand side with Governor Pawlenty. Next. And our P2, MVP2 award that we received for this project. Next. And so I've just kind of tried to encapsulate the benefits here. We have the lower VOC levels, we're cleaning faster, we're dissolving that paint sludge and getting it to separate, we have a moderate evaporation rate. We can use this product to replace xylene, toluene, acetone, delimonene, which with the reduced VOCs would benefit many people. Next. And we've used it to remove adhesives and underbody rust coating, overspray on the automotive surfaces. So here we're able to remove e-coating before it's cured, but after the e-coating is cured, the product will not damage your automotive surface. So we can take out greases, oils, tars, asphalts, paints. You can use in floors, walls, various equipments, construction equipment, anywhere you're going to have some sort of paint or a tar or a sap or
something
greases, oils, anything.
Yeah. So what I found, and I started taking this around to my customers. I have a bunch of industrial customers within Minnesota, and trying it on degreasing, cleaning up some of their machines, their CNCs, the outside of any lathes, big punch presses. And what we found was that it was cleaning off all the grease. It was brightening up the paint that was already there, but not taking it off. And so people really like it. And this is in a non-paint application. They use it for paint, or for floor cleaning, in a bunch of production stamping plants. It's being used all over the place now. So, you know, within our customer base, and we sell it as OSR 17 now. It was Ford Sludge Remover. Again, that name came from Ford Motor Company just submitting the project, and it got that name. So really what it is overspray remover. That's what gets everywhere. So in order to make that part of the name, but then not also pigeonhole the product into just being used for paint application, we just came up with OSR and 17 for the 17 transitions she made in chemical formulation. So that's where that came from.
Next slide, please. And both Rich and I are involved with LubeTech, and here are our emails if anyone would care to, if you have questions that you might have outside of this webinar that we could be emailed, and we'd be very happy to answer any and all questions. And is that the last slide?
Yeah.
Okay.
We have one question. Although the FSR has lower VOC content than the old solvent, did the FSR have higher levels of other air contaminants such as HAPs?
The HAPs are reduced from the overall wash solvent and the xylene products. We are in the vicinity of we reduced the HAPs to probably about 30% of the total formulation.
That's the only question we've received thus far. Has the product been tested on the actual paint spray nozzles?
Yes, it has. I don't know how much more to get into on that one. We ran that through a variety of tests. We would actually go through paint blocks, and we would actually clean the paint gun with the product. So we would put it in a small beaker type attachment to the gun, and then spray through the nozzle, and then go to the next paint when we were trying to see if it was okay to run with. That's how far we went with that crater test.
In addition, and if people are interested in this, we could certainly email it. We conducted a series of compatibility studies on various resins and plasticizers, gaskets and seals and piping materials, and so we do have that compatibility study available, because when you deal with paints, we have to be able to break those bonds, plasticizer bonds and so on, in the uncured material. So there are certain materials, seal materials, for example, or piping materials, that we have to be aware that the FSR on prolonged contact can possibly craze or crack or embrittle various materials.
And one last question. Can the cleaner be used to flush paint lines?
That's a good question. I was intimately involved with that project, or that type of process, for about 7 years with Gage Products Company. We used very successfully their Cobra cleaner, and we also did solvent flushes. We never did get that far as to trying to see if we could clean and go from, flushing their, emptying the paint lines to circulating the FSR within the tank. We wanted to do that. In fact, what we did at the end was we didn't actually try and clean one. What we did was we emptied one out and we filled the paint line with FSR. So it worked inside the system. And now that you're spurring my memory here, this one was actually supposed to have been cleaned. Remember this? Mm-hmm. It was supposed to have been cleaned and mothballed. So visually, it was totally clean on the outside from the tanks. When we put the FSR in there and circulated it through, we got metallic blue tons. It was dark, deep metallic blue inside that paint line again after the end when we were looking at the project or the product. So we emptied that out, and then we put new clean FSR in there. We got a little bit less blue, and then we pulled that out, and then we put it in there, and it was totally clear again. So while we thought that paint line that was metallic blue was totally clean, and we mothballed it as such, which if that was going to be a paint line that was active, we would have went and put a white in there or whatever it was, assuming it was clean, and when we found out that it really wasn't. So that's a great question, and it's probably something I should have brought up earlier, but I didn't think of it until that question was asked.
Angela, are there any more questions?
Just if the presentation will be available, it will be available on PPR's website, which I posted in the chat box. Probably in the next day or two. The file size is rather large, so we're going to have to put it in the files up in separate chunks. And that's it.
Great. Thank you for doing the controls, Angela, and thanks to Rich and Punch as speakers. We really appreciate your sharing your story with us. Thanks also to all of our attendees today. We hope you got something out of it and can make use of a product like this and see how it demonstrates safer chemistry that LubeTech has moved toward. We want to remind you to complete the survey that you'll receive shortly after the webinar is over, and be sure to register for the June 12th webinar on safer chemistry resources at p2.org/challenge. And finally, you can take a look at our website, which is p2.org/challenge, and consider joining the Safer Chemistry Challenge program. You can also contact us with any questions that you may have about this webinar or others, or to make contact with Rich and Punch, whose emails are listed there, at saferchemistry@gmail.com. So thanks again, and enjoy your week.